Welcome to Python for Scientific Computing 1. In today's video, we'll talk about functions. We've been using functions throughout this course. For example, we made use of the length function to get the length of a list. We also saw that we could access functions from libraries. For example, we saw that we were able to import math library and access functions from it. Similarly, we imported the random library to get the random function which generates random numbers between 0 and 1. In addition to these, Python also provides us with tools to write functions. The focus of today's class is understanding what type of functions can we write in Python and what is the syntax for writing functions. Functions are essentially a set of commands that are grouped together. Functions have inputs and they take these inputs and create outputs. Why do we write functions? We write functions because functions help us to logically group a set of calculations in a way that it makes sense. And more importantly, once you write a function, you can call that function anywhere in the program and reuse it. So that way you're efficient with the way you're coding. You're writing your code once, making sure it works. And once it works, you don't have to rewrite that code over and over again. You can simply call the function and make use of code that's already been written. This idea of using functions comes from what is known as the functional programming paradigm. Python has some elements of functional programming paradigm embedded in it, so it makes it a very versatile programming language for scientific computing. In Python, there are three types of functions. The first type is the built-in functions, which are native to Python. For example, the length function that we have seen to get the length of a list. Modular functions are functions that are available to us from an external library. For example, we saw functions coming from math library, which we had to import, or the random library, which we imported to get the random function. User-defined functions are functions that are written by the users, and today's lecture largely focuses on user-defined functions. You define a function as part of your script, then that becomes a user-defined function. To define a function, you make use of the def keyword, def, all in lowercase, and the def tells the Python interpreter that you want to write a function. And that function has a name. Here I'm calling it fname. And the function has inputs. Those inputs are what are called arguments of a function. This def keyword name and the arguments end with a colon. This colon again indicates that there is a code block, and the code block has the set of calculations that we want to do. The code block ends with a keyword called return and the output that needs to be returned. So notice that the return is indented as well, so it is part of the code block. Once you have the function written and loaded into the memory, you can call the function using the function name and providing the argument. So fname is the function name, arguments are the inputs, and then there is a return value associated with the function, and that is the value that the function returns. And if I want to call the function, I call it using the function name and I provide the inputs. So let's look at an example. Here we have a function called div2, that is the name of the function. The function takes two arguments, a comma b, and this def keyword denotes that I'm interested in creating a function. And this colon here denotes that there is a code block that follows, which is associated with this function. The code block here has one line, c is equal to a over b. So it takes the input a, divides it by input b, stores that value in c. And then it returns this value c to the program when it's called. So if I were to load this function into memory and then call the function div2 with arguments 5, 1, it assumes that a is equal to 5, b is equal to 1. So c is equal to 5 over 1, which is 5, and it returns the value of c and gives me 5.0. There are two ways in which you can pass arguments to a function. Passing arguments by position and passing arguments by keywords. Again, let's look at an example. I have the same function div2 a over b. C is equal to a divided by b, return c. One way to do is I'm going to call this, once this function is loaded into the memory, one way to do is to call this function div2, and I'm going to pass arguments 5, 1. And whatever is the output, I'm going to store it in AA, and here I'm printing AA. When I do this, what happens is it takes 5 and assigns, since 5 is in the first position, it assigns it to A, which is also in the first position of the function. So the function call has 5 as its argument, and the function itself has A as an argument in the first position. So they are matched, and it takes the value. Then it takes 1 and gives it to B, because 1 happens to be the in the second position, and B happens to be in the second position. So this one-to-one match, the positional match, is how we can send functions. We don't need to say A equals 5 and B equals 1. We can simply send 5, 1 with the understanding that 5 will go to A and 1 will go to B. If you want to pass arguments using keywords, then we specifically use the keywords of the function A and B and assign values to it. For example, here I'm creating another object called AAK, and I'm calling the same function div2, but this time I'm saying B is equal to 1, comma A is equal to 5. I'm not sending 5, 1 or 1, 5. I am saying that B, even though it's in the second position here, I'm saying when you say B, give it a value of 1, and when you see A, give it a value of 5. Keyword arguments are useful when you have a lot of variables that have to be passed as arguments. Many of these variables oftentimes have defaults, so you don't have to give them. But you have to be very careful as to where those default variables are, so it's a lot easier to send using keywords. On the other hand, if you have 1 or 2 arguments, the positional way of passing arguments is easier. What happens internally when arguments are passed to a function? Most computer programming languages either pass the arguments by value or by reference. When an argument is passed by value, what that means is that the copy of the value is passed to the function. And when we say pass by reference, what we mean is that the address of the variable is passed to the function, which means the function is free to modify the contents of that variable and change the variable. Python uses what is called a pass by assignment or pass by object reference. So let's look at pass by value. I have defined a function sub3, which takes a single argument b. What I'm doing is I'm printing initially the ID of b. This ID function here, ID of b, gives me a human readable address of b. So it is printing the ID or the address where this b is stored. And then the next step, it takes the b, subtracts a value of 3, so minus equal to 3 means it takes the original value of b, subtracts the value of 3, and then it prints the ID of b after this modification using this print statement. And then it returns the new value of b. So if I were to pass 4 to this function, what will happen is the function will take 4, print the ID of where that b is initially located, and then it will subtract 3 from that 4, so I'll get a value of 1, and then it'll print where that value of 1 is stored, and then it returns me that value of 1. What I'm doing in the main program is I'm also seeing where is this y, which I have defined in the main program, where is it before I call my function, what is the address of it before I call this function, and what is the address after I call the function where I'm passing that y. So these are the results. So ID of y before the call, it's a fairly long number, but if you look at the last 3 digits, they end with 920. So this is where y was stored before I called the function. When I call the function b, which is this line right here, the second line right here, or the first line of the code block, it is sharing the same address. If you notice, the last 3 digits are the same, and so are the other digits. So essentially, both b and y have the same address at this point. In other words, b knows the contents of y because it knows the address of y. Now, after b has subtracted 3, notice it is writing it in a completely different address. The last 3 digits of this address is 824, whereas the last 3 digits was 920. So this b, upon modification, was written elsewhere. What that means is that it copied what was in the original address, made a copy, subtracted 3, and wrote it elsewhere, wrote it in that new copy, new address. So there is a change in address. On the other hand, if I come out of this loop and print the ID of y, which is what was sent into the program, the address is the same with 920. So the address of y has not changed, whereas the address of b has changed. This is because y was passed to b as a pass by value, which means it said, here's my address, go see what's in it, but you can't take anything from that address. If you want, you can make a copy and work with that copy, but you can't modify the contents of that address. That's what pass by value is. What happens when we pass by object reference? In this case, we again pass the address of the variable, but no copy is made inside the function. So the function simply takes whatever variable is there and essentially changes it if it has to. So for that, let's look at another example. Here I have defined a function app. It takes in 2 arguments, z and an x. So z is a list and x is a number. I'm printing essentially what is the address that the z is pointing to at the start of the function. Then what I'm going to do is I'm going to take the value of x and append it to the value of z. And then I'm going to return that z, but before I do that, I'm going to print the ID of z after things have been appended, after this x has been appended. So I'm modifying z by appending x. And then I want to see what was the address of z before modification and after modification. In the main program, I am defining a list x. I'm going to print what the contents of that list are. It should be this 1, 2, 3, 4. And then I'm also going to print the ID of x or the address of x before I pass it to the function app. And then I call the function app. I'm passing x, which is a list, and a constant 5, number 5. In there, it has 2 IDs. It says, okay, what is the value of z that is being passed? Remember, the z is being passed as x here, and the value of x is 5 here. So remember, I'm passing it by position. So I want to know what is the ID before appending, after appending, and then what is the value of x after the function call. X before the function call is 1, 2, 3, 4, which is to be expected. And the ID of x before passing it to the function ends with 9760. And the ID of z before anything happens inside the function is the same address. So essentially, this z and this x are sharing the same address. Now, when I do z dot append x, which is append this value of 5, the address still stays the same. And when it comes out of the main program, x also has the same address. So here, what is happening is the function passes this list x to z of the function. And what it's saying is, here's the address. If you want to change it, go change it. That's the difference between passing by reference and passing by value. So when we pass by object reference, depending on whether what you're passing is mutable or immutable, Python will either act like it has been passed by value, in which case it makes a copy. Otherwise, it assumes that it is passed by reference and it doesn't make a copy but works on the original. Functions can take many different types of arguments. Any data type, integer, float, boolean, complex, or all string, they all can be sent as functions. Data structures like lists, tuples, dictionaries can also be sent in as arguments of the function. And one thing very unique about Python, rather unique about Python, is that you can also send functions as arguments. Okay, this is again a big part of the functional programming paradigm that some programs have. Python is one of them. So let's look at an example of how to pass a function as an argument. I have defined a function called calc, and calc takes x, which is the angle in degrees, and fun, which is basically a trigonometric function. And then what it does is it takes this x in degrees and essentially converts that to radians. So example, if I pass 30 degrees, it'll take 30 divided by 180 and multiply it times 3.14, the math.pi, okay? And takes that as x and then passes that x, which is the angle in radians, to a function and calculates y and returns that y. Now this fun is being passed as an argument or as an input to calc. What I want to do is I want to call calc once this function is in the memory, send 30 degrees. So I want to convert, and then I want to send the function math.sin. To send the function math.sin, I need to import math, which I'm doing right up here in the top. For fun, math.sin. For x, it's 30, converts this 30 degrees to radians and gives it to math.sin. Math.sin of 30 will give me a value of roughly 0.5. It's just some round off error that you're seeing here. And notice when I print type of function inside my function that I have here, cal, it tells that it's of the class built-in function or a method. In addition to regular functions that are defined using the def object, there are something known as lambda functions or single line functions in Python as well. Lambda functions are again another big component of procedural programming. Lambda functions can be written without any name, and you can actually assign a lambda function to an object. Again, it's easier to look at an example. Here, I have an object called lfName, which is a lambda function. So I'm saying that is equal to this lambda. Lambda indicates that I'm writing a lambda function. Lambda function means there's a single line function, few inputs. Here I have only one input x, and I'm putting a colon, which is the syntax, and then the calculation that I need to perform. There is no need for return. There is no need for parentheses to send arguments and such. It's simply lambda space x. The name of the object is the name of the function, and the function performs this calculation. So it takes the value of x, takes its square root, and adds 2 to it, and then returns that number to this via this variable. So for example, now this is the object name. That's the lambda keyword. That's the argument. Those are the calculations. So now if I say lfName4, because lf is a lambda function, lfName4, x is taken to be 4, and it takes square root of 4 plus 2, which is 2 plus 2, and it returns to me a value of 4.0. So this is how lambda functions are implemented. You use the keyword lambda, input, colon, calculation to be performed, and you take all of this and assign it to an object, and you use the name of the object with your input to get to call that function or use that function. So in summary, functions are nothing but a set of commands. They have one or more inputs that yield one or more outputs. Functions are very efficient way to write code. You write the function once and you can reuse it many times. Python offers two types of functions: regular functions, which are defined using keyword and a code block, and then lambda functions, which are simple single line functions. A function can take many arguments, any valid data type, data structure, but you can also pass functions as arguments to functions. And it's always a good idea to write your functions up front because they need to be in the memory for you to use it subsequently in the program. I hope you found the video useful. I will see you back in the next video. Till then, take care and goodbye.